Good morning. Video 7 today. We are going to be installing our hosts. Nothing too complex, and we're not even going to touch Apstra. We're just going to deploy the systems that we're going to use to interact with the fabric. This is going to be vSRX, and it's going to be Linux. I deploy vSRX for LACP. If you're a wizard and you can get LACP to work in Linux, more power to you. I have had nothing but trouble. Maybe it's an Eve thing. I don't know, because I have done this before on Raspberry Pis. It's just a nightmare here, to the point where after 2 days, this is months ago, but 2 days of working on it, I'm like, sod it, I'm just going to use vSRX. First step, we are going to define our host networks. And we've already done that to a certain extent here. If you haven't done that already, do it now. As I deploy my hosts, they're going to be right here. From left to right, it'll be 11, 22, 33, and then into DC2, 44, and 55. Whatever numbering you want. None of this really matters. It's just how I'm doing it. So let's get our vSRXs added. Right-click the screen, click Node. We're doing vSRX, next gen. So we'll do 5, and say BMS. Leave everything else the same. Click Save. We're done. All right, there we go. So let's just line up a few here. 1, 2, 3, and then 2 over here. I'll clean all this up with my symmetry OCD later. Cool. Get them linked. B 9. 1. The reason I'm doing 1 here is because I do 0 down to the hosts. So this one that's single homed will be GE001, and then the rest of them, since they're multi-homed, will be 1 and 2. Now vSRX only deploys with 4 interfaces. One of them's out-of-band management, and the other 3 are revenue. So we're going to use all the revenue ports on the multi-homed vSRXs. That's fine. It's just we're constraining our numbering from 0 to 2 because we only have 3 revenue ports to use. Oh, geez, I set that to FXP. Whoopsie. Better edit that. Delete, redo. You'll see from both leaves I'm doing XE0010 to this host, and I'll do XE0011 to the next. You can do this however you want. You just need to make sure that your cable map in Apstra maps what you're doing here. Hey Pepper, how you doing this morning? Good? All right. Let those birds know what you think, okay? Oops. Ah, my symmetry. All right. A little bit of space here. Perfect. And now let's get our host installed as well. At least deployed. Boot these last. We're going to add 5. You need 2 Ethernets. That's just in case you want to connect one of those interfaces, not permanently, but temporarily, to a management network you might have on your Eve server that gives it access to the internet. This will allow you to install packages. Optional step. I'll note that later on. I obviously don't deploy these with a lot of resources because I don't need a lot of resources. Five of those, 1 CPU, 1024, just as you like. Sometimes I change the icon. I'm not doing that this time. So each of these goes 1-to-1 with one of these vSRXs. And we go GE0 to E0, and then we'll rename everything. Which you do need to do before they power up. If you power something up, you are not going to be able to rename it until you shut it down. All right, starting from left to right. DC1-BMS-1_bridge. I'll copy that so I can reuse it. Edit. BMS2. BMS3. DC2, BMS1. And DC2, BMS2. Right. See, these things sometimes get moved around a little bit when you add the names to them. All right. Now it's just this bit. Okay. Save. Actually, while I'm doing this, I can power these all on. We're going to start with the vSRXs. We'll do the hosts in a second. So we'll power those up while we're renaming these and hear the fans on my Eve server slowly spin up to an even higher speed. I think in the next couple of weekends, I'm going to start moving my lab space, which is on the other side of this wall over here, to behind the wall back there in an effort to isolate some of that noise. All right. There's all the naming. I'm going to pause here, and I'll be back when all the vSRXs are booted up. And we're back. If you've not worked with vSRX before, that first boot can take a little while. Subsequent boots are much faster. I've already logged in. Login's just root. There is no password. I'll have to set that here. Password. It's going to just be Juniper with a capital J for the sake of simplicity. Set the system host name to reflect the device this is. We are in DC1, and this is bare metal server 1. Make sure that's the same syntax. Oh, I'm doing a dash. Okay. Cool. We're going to put this into packet mode. It's in flow mode by default. The way we do that is by deleting the security stanza. This is just going to simplify our life. We won't have to be adding interfaces to security zones. Essentially, we're just going to tell it to behave like a router. Let's see if I can remember this command. Set security, forwarding, which one is it? Options, mode. There we go. Nope, that's not it. Forwarding options, family. It's funny, MPLS, this is INET 4, so this is IPv4. The use case typically for doing this, though, is to, if you have a vSRX that is doing PE functionality, you would turn off flow mode for MPLS interfaces, because flow mode breaks MPLS or really any tunneling interface. In this case, it's a stand-in for just INET, because we'll do family INET 6, which is just normal. I don't know. It still says MPLS, but we're going to put this in packet-based. Do an up arrow, delete a few, do INET 6, mode, packet-based. Great. Now interfaces, edit interfaces. Just the FXP, that's fine, great. We don't need to worry about out of band here. For this particular SRX, it's just this one connection, GE000. So edit GE-000. Oh, and you know what? I just realized I set the hostname wrong. So top set system hostname DC1-BMS-1_bridge, because this is the vSRX. There we go. Oh, nothing here. Set unit 0 family Ethernet switching VLAN members 101. Now we'll have to define that as well. This is not a trunk interface, so set unit 0. I put this in discreetly. It is by default not a trunk, but family Ethernet switching interface mode access. Great. Top set VLANs V 101, VLAN ID 101. There we go. We also need the uplink to the fabric. Edit interfaces, set GE001.0. That also, you can use that notation if you want to just go straight to the unit. Family, Ethernet switching, VLAN, members 101. In this case, it is a trunk. Memory serves anyway. We'll fix that if it isn't. This mode, trunk. Great. Cool. We'll commit and quit. If you change your flow mode on a hardware platform, you have to reboot. No different with vSRX. So request system reboot at now. Yes. I'm going to do one of the multi-homed vSRXs, and then I'll pause and I'll do the rest. You don't need to sit through that. Root, CLI, configure, set system, root authentication, plain text password, Juniper, set system hostname, DC1-BMS-2_bridge. While we're here, we'll just do set VLANs, V102, VLAN ID 102. If you remember, that second device is, oh, I did that wrong. Yeah, you need to be too. Is this box. So this one's for VLAN 2. Set, actually, we'll get into the interface stanza here. Well, let's do this first. Delete and security, set security, forwarding options, family, MPLS, mode, packet, iNet 6, mode, packet, edit interfaces, set GE000.0, family, Ethernet switching, interface, mode, access, because this goes down to our host, up, VLAN, members, 102, set GE. Oh, you know what? There's one other thing we do need to do. Set chassis, aggregated devices, Ethernet device count. We need to have an aggregate interface available, or else we'll set it up in the interfaces part of the configuration and it will not come online. Interfaces. Right, so set GE001. Ether options. Okay, it is that. So we're looking for 802. It's gig ether options on some platforms. The 380, and this is where we pin it to an AE that we'll define in a minute. Done that, copy GE001 to GE002. That'll give us the same config for both. Oh, I guess we got to delete that also. Right, top, delete system, auto, installation. Lovely. Show, perfect. Set AE0, oh, pardon me. Aggregated ether options, LACP active, set AE0.0, family, Ethernet switching, interface mode, trunk, VLAN, members, 102. All right, so we've got our interface that connects to our host. We have the two interfaces that connect up to our leafs. And we have our aggregate interface that is in a trunking mode for the VLAN that is going to be defined for this host. Cool. Top, commit, and quit. And I believe we're going to have to reboot this one as well. And then I'll go through and I'll do the rest. So still coming up. Request system reboot at now. Yes. All right, I'll pause and I'll get the rest of these done. Be right back. Looking at the most important part of the configuration stanza, the interfaces part, We're just going to verify our VLAN memberships based on our design. If we go back here, I talked about this earlier. VLAN 101, 102, 101, 101, 103. 101, 102, 101, 101, 103. Let's power up our hosts. These will not take nearly as long as the vSRXs will. We'll get IP addresses defined on those, get some color coding and notation into the lab, and we'll be done. And in the next video, we will do our day one service provisioning. I'll pause here, let the hosts boot up, and we'll jump back in and walk through one of the hosts. Because we've abstracted the LACP to the vSRXs, the host configuration is pretty straightforward. You can download tooling if you want to. I will likely do that. I will likely do that out of band of this video. Just connect that other Ethernet interface to whatever Eve interface you have that gives you access to the internet, and run your app updates and any upgrades you want to do, and then install whatever tools you might want to use. iPerf, TC, PDump, whatever your preferred network test tooling is. For the most part, this is going to be a reachability focused exercise, so we'll be using ping. I might install a couple things, but I'll do that out of band. Be right back once everything's on. And we're back, and I'm not wearing a hat because it is tomorrow. Pause the video, and I got a text message from my wife saying my son was awake, and thus starts my day. So now it's Monday morning instead of Sunday morning. I've got all of my hosts set up. I've color coded based on the VNI. These are all going to go in the same tenant to begin with, but these do represent the different subnets. The color coding is just so you can quickly see which ones are in the same subnet and don't need L3 to reach each other. These are also our policy boundaries if we build policies later. We've got .101.11, .102.22, .101.33, .101.44, and .101.55. Huh, that's not right. This should be 103. You can obviously use whatever IP scheme you want to use. This is the one that I'm using. So we're going to set up the IP address on one of these, and then I'll just assume you can probably wash, rinse, and repeat for the rest. I'm using a distro of Ubuntu Mate that I got directly from the EveNG website. The default password, it's around here somewhere. I think it's test123. I'm trying to remember if it's capital T. Yes, capital T, EST, 123. Probably won't change that. It's easy enough to remember. And I've got to post it over here, just in case I can't remember it. First boot takes a minute. We'll go in and configure an IP. There's not any reachability since we haven't done our day one provisioning yet, but we will go through and build these. You can obviously skip this part if you know how to IP your Linux box already. If that's the case, I'll see you in the next video. If not, just stick around. All right, edit connections. We're using wired connection 1 here. Click the gear. Go to V4 settings and change this to manual. Now you can run DHCP. There's no reason you can't. It's just I'm not doing that. 192.168.101.11 VAS24 gateway. When we set up our Anycast gateways in the fabric, we are going to set them up as .1 for these different subnets. And then yeah, we do want to add a route because we're going to be routing between subnets. So we'll just do a default. Actually, if you do have a second interface that you connect to the public internet to get packages, you can leave this. You can make this default is what I'm saying. This would be all zeros, but if you're ever going to have them connected at the same time, it might be a good idea to put in specific routes. Now, when you build out a fabric, you're going to need all from DHCP. So this is just not something you'd normally have to deal with in production, but for the sake of a lab, let's see here. 168.101.1, great. Add, and 192.168.103.0/24, 192.168.1.1. Great. Okay. Save. And that's it. I'll do this for the rest. I'm going to spare you that because there's nothing to show once it's complete. Next video, we're going to go through our day one provisioning. We'll build our VNs, our VNIs, our initial route policies, and we'll get these hosts talking to each other. Hope to get that one out soon. As always, thank you for watching. I really do enjoy putting these videos together. I hope you have a great rest of your day, and I'll see you in the next one. Take care.